Welcome to month 4 of the Architect track. Today we're talking about platform engineering and developer experience. This is one of the most consequential shifts in how engineering organizations operate. The realization that your internal tooling, your CI/CD, your infrastructure provisioning, your developer workflows, all of that is a product, and it needs to be treated like one. Platform engineering is not a new ops team with a different name. It's a fundamentally different approach to how you enable your engineering organization to deliver value. The best platform teams operate like product teams with internal customers. They do user research. They measure satisfaction. They iterate based on feedback. If your platform is just a Terraform repo that one person maintains, you haven't built a platform. You've created a bus factor of 1. By the end of today, you'll have designed an internal developer platform from the ground up: architecture, self-service portal, CI/CD, metrics, and adoption strategy. This is the full stack of platform thinking. Here's how we'll spend our time. Hour 1 covers the foundations, platform engineering principles, team topologies, which provides the organizational model, and a cognitive exercise where you'll analyze real developer pain points. Then in hours 2 and 3, you'll design a complete internal developer platform for a company called Scale-Up Technologies. From architecture through self-service portal, CI/CD platform, and adoption strategy. Hour 4 is presentations and peer review. The cognitive exercise is important because it forces you to think about developer experience from the user's perspective before you start designing architecture. Too many platform teams build what they think is cool rather than what developers actually need. 5 objectives today. Notice the progression: design, create, architect, measure, create. We start with the vision, designing the platform. Then we create the self-service experience. Then we architect the CI/CD backbone. Then we measure whether it's working. And finally, we create the adoption strategy, because the best platform in the world is worthless if nobody uses it. That last point is the one most technical architects miss. Platform adoption is change management. It requires communication, training, incentives, and patience. You cannot force migrate teams to a new platform and expect gratitude. 6 principles that should guide every platform decision. Paved roads make the right way the easy way. If your secure, compliant, well-monitored deployment path is harder than SSHing into a box and doing it manually, developers will SSH into the box. Every time, your platform needs to be the path of least resistance. Self-service, enable without blocking. If a developer needs to file a ticket and wait 3 days for a database, your platform has failed. The whole point is to remove the human bottleneck from standard operations. Golden paths. These are opinionated, curated workflows. Not everything is a golden path. You're not building a platform that handles every edge case. You're building one that handles the 80% case brilliantly and provides escape hatches for the rest. Guardrails, not gates. Automated policy enforcement, not approval queues. Security by default, compliance by default. A developer shouldn't even have to think about it. Product mindset. Treat your platform like a product. Do user research. Track NPS. Have a roadmap. Prioritize features based on impact. Measure everything. If you can't measure it, you can't improve it. Donor metrics, developer satisfaction, adoption rates, all of it. Team Topologies by Matthew Skelton and Manuel Paes gives us the organizational model for platform engineering. 4 team types. Stream-aligned teams are your product delivery teams. They are aligned to a flow of work, a product, a feature set, a customer segment. These are your primary teams. Everything else exists to serve them. Platform teams provide internal capabilities as self-service. Their job is to reduce the cognitive load on stream-aligned teams. A platform team that increases cognitive load is an anti-pattern. And it's more common than you'd think, enabling teams coach and upskill other teams. They fill capability gaps temporarily. Think of them as internal consultants who work themselves out of a job. Complicated subsystem teams own specialist components that require deep expertise, things like ML inference engines, video transcoding pipelines, or payment processing. The 3 interaction nodes matter just as much. Collaboration is high bandwidth and temporary. Two teams working closely together for discovery. X as a service is the target state. Consumed via an API or interface. Low coupling. Facilitating is when an enabling team helps another team build a capability. The key insight here is that the platform team should primarily use the X as a service interaction mode. If your platform team is in permanent collaboration mode with every stream-aligned team, you haven't built a platform, you've built a consulting practice. The internal developer platform has three layers, and the order matters. The infrastructure layer is the bottom: Kubernetes clusters on AKS, networking, databases, storage, and GitOps with Argo CD. This is where Crossplane or Terraform provisions resources declaratively. The services layer sits on top. Authentication via SSO, centralized logging, metrics with Prometheus and Grafana, distributed tracing, and secrets management with Vault. These are the shared capabilities that every application needs, but no individual team should build. The experience layer is what developers actually see: the developer portal, service catalog, API Explorer, documentation hub, and health dashboards. This is where Backstage or Port lives. Here's the critical insight. Most teams start building from the bottom up, infrastructure first. But the highest impact layer is the experience layer. If you only have time and budget for one thing, build a portal. A great portal on top of mediocre infrastructure is far more useful than perfect infrastructure with no discoverability. Think about it this way: how many organizations have great infrastructure that nobody knows how to use? That's exactly the problem the experience layer solves. The service catalog is the core of self-service. 5 template types cover the vast majority of what developers need. Web service, a standard web application with Kubernetes deployment, ingress, database, and full observability stack. 5 minutes to provision, not 5 days, 5 minutes. API service, REST or GraphQL API with Kubernetes deployment, API gateway integration, and authentication, also 5 minutes. Worker service, background job processor with message queue. Data pipeline, ETL or streaming with Airflow. ML service with GPU provisioning and model store. Notice the provisioning times. 5 minutes for standard services, 10 for data pipelines, 15 for ML. These aren't aspirational. They're achievable with good templates. The key is that templates bundle everything, not just the compute, but the networking, the secrets, the monitoring, the security policies. Below that, environment templates. Development is on demand and shared. Review environments are ephemeral. They spin up a pull request and automatically clean up when the PR merges. Staging is persistent and production-like. Production is protected with full resources. The preview environment pattern is transformative. Every PR gets its own deployed environment. Reviewers can test the actual running code, not just read the diff. The developer portal is the single entry point for everything a developer needs. 4 core sections. Home dashboard. At a glance, what's the health of my team services? What deployed recently? Are there any alerts? What can I do right now? The dashboard should be the developer's default browser tab, not a project management tool. Service catalog. Browse templates, create new services, request custom resources. The creation flow should be 5 steps maximum. Name your service, pick a template, choose your environment, configure options, deploy. Done. My services, health status, SO tracking, deployment history with one-click rollback, and deep links to logs, metrics, and traces. If a developer needs to SSH into a box to debug, the portal has failed. Documentation hub, getting started guides, auto-generated API docs from OpenAP specs, architecture docs, and runbooks. Documentation that lives with the code, not in a separate wiki that nobody updates. Technology options range from Backstage by Spotify, which is the leading open source choice, to Port as a strong commercial alternative with faster setup. Custom builds are tempting, but almost always a mistake unless you have a large dedicated team. The CI/CD platform is the backbone of deployment velocity. Let's walk through the standardized pipeline. Build stage, compile, unit tests, lint. Target, 3 minutes. This needs to be fast enough that developers don't context switch while waiting. Security stage runs in parallel. Source scanning, dependency vulnerability scanning, container image scanning, secrets scanning. Target 2 minutes. Parallel execution is critical here. Running these sequentially would add 8 minutes. Test stage, integration tests, and selective E2E tests. Target 5 minutes. Selective is the key word. You don't run every E2E test on every commit. You run them based on what changed. Then the deployment stages. Dev auto deploys on every push. Staging auto deploys from the main branch. Production requires a manual trigger, but uses canary deployment. Start at 10%, verify metrics, progressive rollout, then full deployment. Total pipeline target, under 15 minutes from push to production. That's down from 45 minutes. The standardization is equally important. Shared pipeline libraries per language, auto-detected build configuration, and consistent behavior across all repositories. No more bespoke pipeline files that only one person understands. Quality gates enforce standards without slowing teams down. The key distinction is blocking versus non-blocking. Security scan is blocking. If there's a critical or high CVE, the deployment stops. Period. Bypass requires explicit security team approval with audit trail. Unit tests are blocking. All must pass with at least 80% coverage. Bypass requires tech lead approval. Integration tests are blocking with no bypass option. If integration tests fail, something is actually broken. Code quality is non-blocking, so now create checks for maintainability, duplication, and complexity. It warns but doesn't block. This is intentional. Code quality is a conversation, not a gate. Performance testing is staging only. It checks for regressions greater than 10% on key latency metrics. This catches performance problems before they hit production without slowing down the development loop. The philosophy is guardrails, not gates. Automated enforcement is preferable to human approval queues. Every gate that requires a human is a bottleneck. Automate the judgment wherever possible and reserve human review for genuine exceptions. DORA metrics. Deployment frequency, lead time for changes, mean time to recovery, and change failure rate. These are the 4 metrics that matter most for software delivery performance, backed by years of accelerated research. Let's look at the current state versus targets. Deployment frequency, weekly to daily. This is achievable with automated CI/CD. It's mostly a process and culture change, not a technical one. Lead time, 2 weeks down to less than 1 day. This is the time from commit to production. 2 weeks means there's manual process, manual testing, manual approval, or manual deployment in the way. Automate all of it. Mean time to recovery, 4 hours to under 1 hour. This requires automated rollback, good observability, and clear runbooks. When something breaks in production, the question is, how fast can you detect, diagnose, and fix it? Change failure rate, 25% to under 15%. 1 in 4 deployments currently causes a problem. That's why teams are afraid to deploy. Better testing, canary deployments, and feature flags bring this down. The research from the Accelerate book shows that elite performers deploy on demand with lead time under 1 hour, MTTR under 1 hour, and change failure rate under 5%. That's the North Star for platform engineering. DORA measures delivery performance. SPACE measures developer productivity holistically. 5 dimensions: satisfaction and well-being, developer NPS, burnout indicators, tool satisfaction. Measured through quarterly surveys. This is the dimension most organizations skip, and it's arguably the most important. Unhappy developers write worse code, mentor less, and leave. Performance, system reliability, page load times, API latency. Measured through automated monitoring. This is the performance of what developers build, not the developers themselves. Activity, commits, pull requests, deployments, code review throughput, measured from Git and CI metrics. Activity alone is a terrible proxy for productivity, but combined with the other dimensions, it tells a story. Communication and collaboration, PR review time, knowledge sharing, cross-team contributions, measured through tool integration, slow PR reviews, are one of the biggest hidden drags on developer productivity. Efficiency and flow, cycle time, flow efficiency, interruptions, context switches, measured through value stream mapping. This is where you find the waste. The key insight from space is never use any single dimension in isolation. A developer who's high on activity but low on satisfaction is heading for burnout. A team that's high on performance but low on communication is building silos. Before we dive into the main challenge, let's practice DX analysis. You have survey results from 50 developers, 6 pain points with severity scores, frequency, and impact ratings. Step 1. Plot these on an impact effort matrix. High impact, low effort equals quick wins. These are your first sprint. High impact, high effort equals strategic initiatives. These go on the roadmap. The manual deployments at severity 4.5 with critical impact. That's your number one priority. It's high impact and medium effort. Automating deployment is a well understood problem. Step 2. Apply the 5 whys to the top 3 pain points. Why are CI/CD pipelines slow? Because they run sequentially. Why? Because no one optimized them. Why? Because there's no ownership. Why? Because there's no platform team. Root cause. Organizational, not technical. Step 3. Propose solutions with estimated ROI. If you reduce CI/CD from 45 to 15 minutes and developers run pipelines 4 times per day, that's 2 hours saved per developer per day across 300 developers. Step 4. Create the 6-month roadmap. Months 1 through 2, quick wins, CI optimization, and basic self-service. Months 3 through 4, strategic initiatives, portal MVP, and template library. Months 5 through 6, scale, full rollout, and advanced features. Here's your challenge context. Scale up technologies. B2B SaaS company, Series B, 300 developers, 50 repos, 15 million ARR, growing 100% year over year. The pain is real and specific. Infrastructure provisioning takes 3 days. CI/CD takes 45 minutes. Onboarding takes 2 weeks. Deployments are weekly and manual. Developer NPS is 15. That's terrible. And engineers spend 40% of their time on non-coding tasks. The targets are ambitious but achievable. Infrastructure in under an hour, CI/CD under 15 minutes, onboarding in 2 days, daily deployments, NPS above 40, 20% productivity increase. Your job is to design the platform that gets scale up from current state to target state. This isn't theoretical. Every metric here is based on real companies that have made this transformation. Part 1. IDP architecture design, 40 minutes. Start with the platform vision and principles. Then design the 3-layer architecture with specific component choices. Finally, define the self-service capabilities. For component selection, you need to evaluate options and justify your choices. Backstage versus port for the developer portal. Argo CD versus Flux for GitOps. Crossplane versus Terraform for infrastructure automation. Don't just pick the popular one, justify why it's right for scale-ups context. Part 2. Self-service portal design, 35 minutes. Design the service catalog with specific templates. Create a developer portal experience. Define the guardrails and governance automation. The portal design should be user-centric. Think about the developer's journey. I need a new service. What do I click? What do I fill in? How long do I wait? What do I see when it's done? Part 3. CI/CD platform architecture, 25 minutes. Design the standardized pipeline with stages, shared libraries, and multi-environment promotion. Define the quality gates with clear blocking criteria and bypass processes. Remember, the target is under 15 minutes total pipeline time. That means parallel execution, smart caching, and selective testing. Part 4. Metrics and adoption, 20 minutes. Don't rush this part. The metrics framework tells you whether your platform is working. The adoption strategy determines whether anyone uses it. Design both DORA and space metric implementations. Then create a 3-phase adoption strategy. Foundation with 2 pilot teams, early adopters with 5 more teams, then full rollout to all engineering teams. The feedback loops are critical: Slack channel, office hours, NPS surveys, user interviews. A platform without feedback loops is a platform that will drift away from what developers actually need. 6 deliverables. IDP architecture and roadmap carries the heaviest weight at 25%. It's the core design artifact. Self-service design at 20%, user-centric, practical, real templates. CI/CD platform at 15%, fast, secure, standardized. Metrics framework at 15%, actionable DORA plus space. Adoption strategy at 15%, realistic, phased, feedback-driven. And the DX cognitive exercise at 10%, root cause identified, solutions prioritized. Quality matters more than completeness. A well-justified architecture for 3 layers is better than a hand-wavy diagram of 6 layers. Show your reasoning, explain trade-offs, reference specific tools and patterns. Before month 5, you should aim to accomplish these milestones. Build an MVP of the developer platform, even if it's just Backstage with 2 templates. Get something real running. Onboard 3 pilot teams, real feedback, real friction. Reduce deployment time by 60%. Pick the lowest hanging fruit from your CI/CD analysis. Achieve developer NPS of 40 plus from pilot teams. And create a platform engineering team structure proposal. Who does this work? How are they organized? What's their charter? Required reading: Team Topologies by Skelton and Pace. If you haven't read it. It's the organizational foundation for everything we discussed today. Tools to explore: Backstage for the portal, Crossplane for infrastructure, Argo CD or Flux for GitOps, and the Grafana stack for observability. That's month 4. Platform engineering is about treating your internal infrastructure as a product. Build it for your developers, measure whether it works, and iterate relentlessly.